Hi friends, so we look at a new topic which is titled symmetry. So this is one of the topics where we need to pay a particular attention because we may happen to come across with questions to do with symmetry. So in this topic, we are going to look at the following: how to determine the order of rotation, symmetry, and also determine the symmetry of solids, and also to determine plane symmetry. So this is what we have. So we go to the question, rather the definition to do with the symmetry. We are told the symmetry means exact correspondence on either sides of a dividing line, plane, center, or axis. So this is the meaning of symmetry. It means the exact correspondence, meaning what is to the other side, it is also the same with what is to the other side. There is an exact correspondence on either side of a dividing line. If the line is the y-axis, meaning the y-axis is dividing two sides. There's this side here, which I will name as side A, which is the same as the other side, which is side B. If the line is x-axis, meaning the side on top there, it must be the same side as the side at the bottom. So this is what we have when we say it is the exact correspondence on either side of a dividing line. So the y-axis or the x-axis, those are the dividing lines, or plane, or center, or axis. So this is what we have. Now let's go to the types of symmetry. We go to the types of symmetry. So the first type of symmetry, it is what we call translation. So to translate a shape, you have to move it. You move it in a straight line without rotating or reflecting it. You move it in a straight line without rotating it or without changing it in any other way. So we describe translation by giving the direction and the distance a shape or an object is moved. So when you are translating something, you are moving it in a straight line without rotating or deflecting it. When you look at these shapes, we have number one, this P here. P has moved from where it is, it has come there. So it has moved in a straight line without rotating. Also this P here, which was here, we have also moved it here. It has also moved in a straight line without it rotating. We have this shape here, which has moved to this shape there, which can also move from there coming here. It has moved, or this shape here has moved it to come there. Actually, it has to be of the same shape as the shape above. So such kind of movement, it is known as translation. It is known as the translation. Let's go to the other type of symmetry. The other type, which is known as the reflection. It is known as reflection. So the second one we have is known as reflection, of which we have mentioned it already. So what is involved under reflection? The notes are: to reflect a shape or object about a line is like placing a mirror on the line and seeing the shape reflected in the mirror. So when you see, if this is a mirror, if you go under transformation, you find that this line, it is known as a mirror line. So all these lines we are seeing there are known as the mirror lines. So if we place this A here, this triangle A, because there's a mirror here, it will reflect exactly the shape which will reflect in the mirror. So that one is known as reflection. So this is what we have under reflection. Why? Because there's a mirror line in between which has made these shapes to reflect. Okay, to reflect in the other side of the mirror or of the line. So now we go to the third one, the other type of symmetry. So we have another one which is known as glide reflection. So under glide reflection, we are saying to create a glide reflection, we combine a reflection with a translation along the mirror. So we have a reflection and also a translation along the mirror. So when you look at this one, A and C, this is a reflection, not reflection, but translation. That is the translation of shape A. But this shape here, this which we are seeing here, this is a reflection. So when you combine the two, the translation and also the reflection, you form what is known as the gliding reflection. The gliding reflection. So it is a combination of two, reflection and also translation. So now let's go to the fourth one. The fourth one, which is known as rotation. So to rotate a shape or an object, we turn it through an angle about fixed point. So we have a fixed point, which is this fixed point here. We have turned this P, we have turned it the first way, it has come there, and we have turned it again, it has moved that side, and we have also turned it further, it has gone that side. So that is what we call rotation. So we are saying the point is called the center of rotation. The letter P, we are seeing the letter P there on the diagram. Okay, the letter P has been rotated in a clockwise direction through 90 degrees. When you look at this angle which has been formed here, by the way, this is what we have. We have something like this where we have the center here. The letter has moved, this is 90 degrees. Again, it has moved the other 90 degrees. Again, it has moved the other 90 degrees. And finally, if it can move further, it will still move 90 degrees to go back to its original shape, the way it was at first. So this is what is known as the rotation. So letter P has been rotated in a clockwise direction through 90 degrees 3 times. It was rotated here 1, this is 2, and that one is 3, or time number 3. Each position after rotation is called an image of the original. So all these are known as the image. This one is also known as the image. Even that one is also known as the image of what? Of the object or the original shape. So all these are images. So this is what we have under rotation. Let's meet again in the next lesson where we're looking at the determine the order of rotation, where we're going to look at the order of rotation. Thank you.